Hello everyone, you're welcome once again to another class. In our mathematics class today, we'll be looking at conversion of fractions to decimals and decimals to fraction. That's what our focus will be on, but before we move on to that, I'll quickly like to go over what decimal and fractions are. I know we have done this in our lower classes, but I'm just going to remind us of what we already know. So fractions, like we know, are parts of a whole, and decimal numbers are those numbers that contain whole numbers and fractions, and they are usually separated by a decimal point. Decimal numbers are those numbers that are a mixture of whole or full numbers and fractions. Remember, we said fractions are not whole numbers, they are numbers that are part of a whole. So when you have whole numbers mixed with fractions, they are called decimals or decimal numbers. And the whole numbers are usually separated from the fractions in the number by a decimal point. These two numbers, the whole numbers and the fractions, are usually separated by a decimal point in decimal numbers. Okay, so let's quickly take a look at what we have right here on the board. Let's take this to be a full pizza, and then this is half of this pizza. You can see we already looked at fractions before, and this is how half is represented. One part out of two parts. How did we arrive at two parts? Remember, this whole, if it's shared in the middle into two parts, this become one part here, and then you have two parts that form a whole, two parts that come together to form one whole. Now, if you take one part out of these two parts, you have something like this, okay? And how do you represent it? Because it is one part out of two parts, you write it as 1/2. Now, I'm writing this deliberately because I know you know fractions already, but I'm trying to get somewhere, to help you get the relationship between fractions and decimals. Now, let's look at this number line we have to the right here. This starts from 0 to 1. I want to use this number line to try and help us see how this half can be represented as a decimal number using this number line. So let's take this whole, which is 1, to be the range of this decimal, of this number line. So this left extreme end here is 0 point, and the extreme right end here is 1. So between this beginning and the end is just one whole. Now let's come back to the fraction here. This half that we see here, what does it mean? The whole was split into two exact equal parts. That means this is exactly half of this one. It was split in the middle, right in the middle. So if you look at what is on the left side, it's exactly the same as what you have on the right side of this mark, right? It's split in the middle. So one of the half, or one of the two parts, is what we have here. So how do we get that point here to represent half? Now you also look at this line from 0 to 1. And mind you, from this 0 to 1, you have 10 equal, these marks are 10 marks with equal spacing. They are spaced out equally, and the marks are from 0 to 10. So from here to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But mind you, all these numbers are between 0 and 1. That means they are not up to 1. Whatever number that will be seen here is not up to the number 1. It's in the fraction form. So let's list out the numbers first of all. So here is 0, so here is 1. I hope this is right. Okay, here is 2. Here is 3. Here is 4, 5, 6, 7, 8, 9. And the last part here is 10. So what are we trying to show? We're looking for the midpoint, the middle. So the middle, because the middle or the half point is what represents this half here. So we're going to look for the middle point, the half point of this range from 0 to 1. And that is what will represent our half, so that we know how to show 1.5, because what you have here is 1 full pizza and a half. So it is written like that. 1 whole number and then a half. So this is what we're trying to see, how it will be written in the decimal form. Okay, so what part do you think is in the middle of this number line? Right in the middle. Let's see. So from here, let's start from here. So if you have 1, you move from the extreme end, you also have 1. So we move 1 step forward, we move 1 step. We want to meet right at the middle. That's what we're trying to do. So we move 1 step here, we move 1 step here. We move 1 step here, we move 1 step here. So you see we're getting to the middle. And then there's just one number, and that is the number 5. So that means where the number 5 is the middle of this number line. And that is exactly what we're looking for. But because this number, or these numbers, all these numbers you see here are less than 1, before you write them, you're going to put a point. 0.5. The middle point we are looking for that represents this half, or this half, is the number 5, the point where you have this number 5. Now remember, we said that decimals are numbers that contain whole numbers and fractions. Fractions are less than 1. And remember, all these numbers here are less than 1, so they are fractions. So if we are picking out 5 here, remember, that means 5 is a fraction. Okay, let me leave this out first. So they are whole numbers and fractions, and they are usually separated by a decimal point. So if you come back to the picture of the fraction we have here, we have 1 whole, and then we have a half. And this is the 1 whole, right? So our 1 whole now shows up here, which we already know. Remember, is the half we're trying to determine by using this number line. So we have our 1 whole, and now we have found our fraction in the decimal form. It's the number 5 that represents that fraction half. So what do? From what the definition says, it is separated by a decimal point. So your 1.5, if you're going to write it in the decimal form, is 1.5. That's 1.5. So there are other ways we can determine the fraction part of decimal, how decimal is represented in fraction, half fraction. We're going to look into all of that, but I'm just trying to bring you to the basics, the very basic level, of trying to figure out how a fraction can be located using a number line to represent the decimal form. Okay, so to get to convert a fraction, yes, to decimal form, all you need to do is divide the numerator. Remember what your numerator is, the number at the top, by the denominator, that's the number below. You divide the number at the top by the number below, the numerator by the denominator. So let's look at the example we have before us here. So we are trying to divide 3, in this case, by 5. We're trying to divide 3 by 5. Now what do we notice? 5, which is the divisor in this case, is bigger than the dividend, which is 3. 5 is bigger than 3. So in mathematics, if an operation like this is not going to be possible because you can't say 3 divided by 5, what you do is you write down your 0 and you put your point. So when you do this, you now add a 0 to help 3, to enable 3. Okay? This is like addition to 3. You are boosting 3 so that the operation can be carried out. So since 3 is smaller than 5, in mathematics, whenever you come in contact with such operation that is not possible, first you put down your 0 and you put your point. This point is called the decimal point. The decimal point is very important. So after you add that point, you bring your 0 and add it to the numerator. Now the numerator has become a bigger number, which is 30. So the 3 has become 30. Now you can divide. So check how many times can 5 go into 30. When you divide 30 by 5, what do you have? You have 6. So to convert 3 this number, this fraction here, 3/5 or 3/5 to decimal, it's simply 0.6. Okay, let me write it out in such a way that someone won't get confused. Okay, so we have 3/5, then we go over here. Okay, so here we now have 0 point, and I'll write my 30/5, 0.6, just to show where we started from. Okay, so we have this 0.6. Okay, we're going to take another example. So the next example we're going to look at is to convert 3/4 to decimals. That's 3/4. We're converting it to decimal number. So here we go. We have 3/4. You can use long division method, okay? Like what I just did now. You can use long division method, which goes this way. You can write your 3 here because 3 is the dividend, remember, and 4 is the divisor. Okay? I used a method just now. The first one I used now is just like maybe it's just direct division method. But let's try the long division method here. So we know that 4 cannot divide 3, right? So 4 divided 3, that's a 0. So you do 0 times 4 is 0. When you subtract, you bring down 3. Add your point. And at this point, you're going to add 0 to this number here. Okay? Then you now do 30 divided by 4 is 7. Okay? So 7, sorry, after the point you put the 0 here, which is the one you bring down here. Okay? Sorry about that. Now 30 divided by 4 is going to give you 8. 7 rather. 30 divided by 4 is going to give you 7, which is what we have here. So 7 times 4 is 28. Now we do our subtraction. 0, we can't remove 8 from 0, so we do that. Now we have 10 here. 10 minus 8 is 2. Okay? This number now is 2. 2 take away 2 is 0. So we have 2 here remaining. Now, the thing is, if you were dealing with whole numbers, you would call this a remainder, okay? But already this is a fraction, so you might as well just add 0 to it so that you can continue your division. So now you have 20. So 20 divided by 4 is 5. 5 times 4 is 20. So if you subtract, you have 0. So nothing left to work with again. Okay, so I hope we can see that. You have 20 and 20, that gives you 0. Now I'm going to go over it again, okay, for clarity, and then we use the other method to check. All right. So let's go again. 3 is the divisor. Remember, we are dividing the numerator by the denominator, so we arranged. So you have 3 here, you have 4, the divisor outside. So 3 divided by 4 is not possible, so you put 0 down and you put your point. At that point, you add 0 here. Since 4 can divide 3, you put down your 0, put a point, and then you add 0 to the number. You have already shown, by writing this 0 and a point, you have already shown that this number you have here can be divided by the divisor. So you have helped it now by adding 0 to it. But that is shown by this 0 and the point here. So now you have a new number here. This 0 has empowered 3, so we can now divide 30, the new number, by 4. Okay, so 30 divided by 4. 30 divided by 4, you have 7. Now 7 times 4 is 28. You subtract. When you subtract, you have 2 here. That's 30 minus 28 gives you 2. Now, I said if we're dealing with whole numbers, You might just stop here and call this a remainder or point, anything. But already this is on the side of decimal. It's already point. It's already less than 1. So you might as well just add your 0 and continue your division. So when we add 0 to these two, we have 20. So you see 20 divided by 4, that gives you 5. 5 times 4 is 20. Then when you subtract, you have 0, 0. There is nothing left to divide. So our answer is 0.75. That is what 3/4 is in decimal form. Now the first method we used is the direct one. We can just quickly try that to see if we're going to get the same answer as this one. So that one we just simply said 3/4. Then we now can 3 divide 4? No, 4 is bigger than 3, so we write down as 0 and put a point to show that. Let me just take this back a bit because it's going to run into the other. So here we have 3/4. Okay, 4 can't divide 3, so we write down 0 and now point. And at that point, we introduce 0 to the numerator. We've already shown by writing down 0 point that the numerator is smaller than the denominator, so it needs help. And that help we have given to it by adding this 0. So the number now, the numerator now becomes 30. That's become 30. So how many 4s can we get from 30? If you know your multiplication table, you know that 4 times 7 is 28. 4 times 8 is 32. But this number is not up to 32, so it can't be 8 times. So it has to be 7 times. Now you write down your 7. Remember there is a remainder of 2, right? There's a remainder of 2. So that 2 that is the remainder, add 0 to it. It gives you a new number of 20. And 20 divided by 4 is 5. And 5 times 4 is 20. So there's no remainder. And that is our answer. So we can see that whether we use this method or we use the long division method, we are going to arrive at the same answer. So whatever method is okay with you, whatever method you're comfortable with, you go ahead and use it. Okay, but the important thing to take note of is you are dividing the numerator by the denominator. Don't say because you see the numerator is smaller than the denominator, you invert them. You now make the denominator your dividend and then the numerator the divisor. No, it's very wrong. You are dividing the number at the top by the number below. Okay, so that is what you arrive at, 0.75. Let's take one more example. So the next one we're looking at is, this should be our third example, is 5 out of 7. We need to convert it to decimal. So here we go, 5/7. We also try and use the two methods, okay? We use the two methods, but let's start with the long division method. So here we have 5 and here we have 7. All right, so 7 divide 5. We know that 7 can't divide 5, so that will be 0, right? So 0 times 7 is 0, so we put our point here. Now we bring down, we write our 5 and we add a 0 to it. You can actually add a 0 at this point, okay? But the important thing is, make sure you note down the 0 and the point at the top before you introduce the 0 to the numerator or the dividend. Before you add the 0 to the dividend, make sure you put down your 0 and your point, because this is what indicates that the original dividend is smaller than the divisor, okay? So you bring that in to before you can continue the calculation. So now we have a new number, which is 50. So we're going to do 50 divided by 7. Again, we come to our multiplication table of facts. It's very important. You know, we always tell you that whatever you are learning, you're learning it so that it will enable you to gain an understanding of what is coming. because knowledge is like building a house. You keep building upon what you have. So here we're going to go back and check with our multiplication facts. 7 times what will give you 50? Now, if you know you can't get 50 on the dot, 7 times what will give you the closest number to 50, but that is not bigger than 50. 7 times 5 is 35. Wow, we still have some space. 7 times 6 is 42. Can something still go? Think so. 7 times 7 is 49. If you do 7 times 8, you get 56, which is bigger than 50, so it can't be 8. So it is 7. 7 times 7 is 49, so we can only get 7 sevens out of 50. So 7 times 7 is 49. What do? You subtract. We take 5 here, take 1 there. So you have 10 minus 9 is 1. 4 minus 4 is 0. Okay? Remember, I said that we are already on the side of decimal. If we're dealing with whole numbers, you would call this your remainder. Or, if you want to still continue working with this, you can put a decimal point, and then put a decimal point now before putting whatever answer you get from this number. Now, but we already have the decimal point. This number is already in the decimal, so no need for worries. Just add 0 to this number. So it becomes 10. Continue your division. 10 divided by 7 is 1. 1 times 7 is 7. You subtract, you have 3. Right? 10 minus 7 is 3. So you can add your 0. You continue. Now 30 divided by 7 will give you 4. 4 times 7 is 28. I hope we can still see this. 4 times 7 is 28. Let me put it up here so that we can see it. So we have 30 minus 28. That gives us 2. Okay? You can still continue. If you add 0, it's 20. 7 into 20 is 4, remainder 6. Now, you can see it's still continuing. Sorry. 7 into 20 is 2. 2 times 7 is 14. If you subtract, you have 6. Okay? You add 0 to 6, you continue, you have 56. Then you have remainder 4. It continues. Now, there are fractions like that before you hardly get to the end, or you won't even get to an end. You keep going and going and going. Such fractions, this one is an example of that, okay? I don't want us to continue. This is 6. You can now add 0 again to 6. You will continue. You have 56, which is 8. You put 8 there. Then you have remainder 4. You add 0 to 4. You have 35. It will continue. It will continue. So such fractions, decimals, we call them recurring decimals. We call them recurring decimals. They just keep going on and on and on. So if you encounter this type of decimals, when you're doing your conversion from fraction to decimal, if you encounter this kind of thing, you choose when to stop. And it's advisable you stop when you get to the 3rd or 4th digit at most. Okay, after the point. Just stop and do your rounding off. Like now, if you look at 2, and if you are rounding off, it will round to 0. So you throw it away. Just write your answer 0.714. Okay, some people can even round it off to 2 decimal places. It just be 0.71. That will be the end. Okay, so this is an example of I deliberately chose this example so that you can see how sometimes your division will continue and continue like it's not going to end. So at that point, you choose where to stop and round off your answer. So here we can just say that our answer 5/7 is the same as 0.71. You are safe if you write this, or somebody else can write 0.714. It's the same thing. Okay? So This is an example of a recurring decimal, and this is how you handle it. Choose where to cut off, just stop the division and pick your answer. Okay, in maths, there's always allowance made for all these little differences once it comes to decimal numbers. All right, so the next one I would like to show us before we go to converting decimal to fractions is mixed numbers. How to convert mixed numbers. Mixed numbers, remember, are a combination of whole numbers and fractions. So we're just going to see how we can convert that to decimals before we move on to converting decimals to fractions. All right, so to convert a mixed fraction or mixed number to decimals, what you do is you change this mixed fraction to an improper fraction first. You remember your improper fraction where you have a bigger numerator than the denominator. So first you convert the fraction to improper fraction. How do you do that? You multiply the denominator by the whole number, and the answer you get, you add it to the numerator. Okay, we're going to look at an example and you see how it goes. So once after you convert it to an improper fraction using what I just described now, multiplying the denominator by the whole number and then adding it to the numerator, you will now start your division. You now go back to that method that we used, okay, in converting fractions. Remember the examples we considered. So just the difference here is, first you need to convert this mixed number to an improper fraction. And how do you do that? By multiplying the denominator by the whole number. The answer you get, add it to this, and then you write it over the denominator. Your denominator will still remain. Okay, we're going to look at maybe 2 examples and then you understand it better. So you have one whole number 3/4. So what do? We say, no need writing it out. I've already explained it. So you just do 4 multiplied by 1 plus 3. You still keep your denominator. You're still keeping your denominator. So this 4 here, remember I said you multiply the denominator by the whole number, add your product to the numerator, and then you will still keep your denominator. It will still remain your denominator. So you keep it here. So what do we have? 4 times 1 is 4. 4 plus 3 over 4. Our denominator still remains. So what happens? This becomes 7/4. 4 plus 3, that's 7 over this 4. That's what we have here. Okay, now what next? You do your normal division. If you want to use long division, it's your choice. If you just want to go ahead and divide directly, it's your choice. Okay, maybe this time we just divide directly. Let's do the direct division. So how many 4s can we get from 7? We can get just 1. And what do we have left? We have a remainder of 3, right? So this 3 is definitely smaller than 4. So what you do, remember, because it is smaller than 4 and 4 can divide 3, you have to introduce that point. Whenever this point is introduced, it means that whatever is following, any number that is following now, is not a whole number. It's not a complete, it's a fraction. Okay, and why do we get fractions? We get fractions when what is coming is not up to 1 whole. So look at this. This is 3. It's definitely smaller than 4. So if you are going to share 3 stuff for 4 people, you know that everybody can get 1 whole complete because it won't go round. So that's what this point simply signifies, that whatever is coming now is a fraction. So what do? This 3 has to be empowered. So we add 0 to it so that our division can continue. So that we can continue our division. So when we add 0 to 3, the number becomes 30. Now, this 4, you will still use it to divide this 30. 4 into 30 will give us what? How many 4s can you get from 30? You get 7. So you write down the 7. And 7 times 4 is what? Is 28. So when you take away 28 from 30, you have 2. as your remainder, right? So you have a remainder of 2. This is spilling into our work. So that 2 that is remaining, you can still add 0 to it, making it 20. So 20 divided by 4 is 5. 5 times 4 is 20. So you have nothing left to work with. So if you're converting one whole number 3 over 4 to decimal, you're going to get 1.75. Now just look at the two of them and see the similarity. You remember here it has a whole number. This fraction has a whole number, and this one also has a whole number. So you remember when we worked with 3 over 4, the answer we got was 0.75. Okay, that's exactly what we have here. This is 0.75. 0.75 is the same as 0.75. But because we have a whole number already, that whole number is standing in the position of the 0. So you have 1.75, which is the same as 1 whole number 3 over 4. So we can write safely that 1 whole number 3 over 4 is equal to 1.75. Now we can also use the long division method to show this, right? Let's use the long division method to show you. Now we want to use the long division method to solve the same problem we just solved now. Remember, this number is what we are changing to decimal, and first we need to change it to improper fraction, and then we go on to use the normal method of division to get the decimal equivalent. But first you need to to convert to the improper fraction, you multiply the denominator by the whole number, which is what we did there, 4 times 1, and then the product, the answer you get, add it to 3, the numerator, add it to the numerator, and you still retain your denominator, you still leave it there. So 4 times 1 is 4 plus 3, that's 4 plus 3, you still retain your denominator. That gives us 7 over 4. 7 over 4. So that's what we are dividing now. We are now going to divide 7 by 4. Okay, so if we look at the 7 is our dividend and 4 is the divisor. We see that 7 is bigger than 4. So we are not going to write 0 because we can get 4 from 7. How many 4s can we get from 7? 1, 4. So that 1 times 4 is 4. What do? We take away. Remember, division, multiplication, subtraction, and bring down. That's the method, okay? So we write that one here. So when you subtract 4 from 7, you have 3, right? Now 3 is smaller than 4. We can't divide 3 by 4. That means we are going to introduce a point, okay? And once that point is introduced, you add 0 to the 3. So now 3 has become 30. So 30 divided by 4, what will you multiply by 4 to get 30, or in the number closest to 30 but not bigger than 30? Is 7. 7 times 4 is 28. 7 times 8 is 32. 32 is bigger, so it can't be 8. So 7 is the number, and 7 times 4 is 28. So we take away 30. This is 10. 10 minus 8 is 2. We still have a number, so we can still continue our division. Add 0 to 20. Okay, so you have already put your point. So all the numbers that are coming after this point, they are all fractions, so it doesn't really matter. As long as you keep having a remainder, you can keep adding 0 so that your division will continue. Okay, so we had the remainder of 2 here, and we added 0, making it 20. 20 divided by 4 is 5. And 5 times 4 is what? 20. So your answer is 1.75. You see, we still got the same answer like when we use the other method. Okay, so it's just basically the same thing, using long method when you want to convert. But for mixed fraction, you first have to change the mixed fraction to an improper fraction before you can do the long division. It's basically the same thing, only you need to convert it before you do the long division. So at this point, I would like to say that you see the importance of having an understanding of some of these mathematics operations like addition, subtraction, division. You need all those, because for most other problems you will be encountering in maths, you're going to be using all these basic operations to solve them. So that's why you have to pay attention to all of those, okay, when you have them. So next, now we're going to move on to converting decimals to fractions. We're going to look at how we convert decimals to. Okay, so to convert a decimal number to a fraction, there are some steps you need to follow, okay? When you're trying to convert a decimal, remember we just looked at converting fractions to decimal. Now we're going to look at how we can convert decimal numbers to fractions. So the first step is take note of the number of decimal places in that decimal number. Okay? Take note of the number of decimal places. That is, check how many numbers are after the decimal point, or how many digits, okay, are after the decimal point. That is the first thing you need to do to change a decimal number to fraction. Count the number of decimal places in the decimal number. That is, after the point, how many digits or how many numbers do you have after the point to the right. Now, once that is determined, you are now going to write that decimal as a fraction over a power of 10. What does that mean? Whatever the decimal number is, you will now write it on top. You draw your short horizontal line. You remember how we express fraction? There's always a number at the top and a number below, separated by a short horizontal line. So this is your decimal number. After you have checked how many numbers you have after the decimal point, you will now write the number itself as your numerator. You rule your line, and then you write a power of 10 under. What does that mean? You write either 10 or 100 or 1000 or 10,000, depending on the number of digits that are after the decimal point. For instance, if you have just one number after the point, if the number, for instance, is 1.2, that means you're going to write 1 and 2. You will now throw away the point. You won't need it again. So you now write 1 and 2, which is 12. You rule that horizontal line and you write 10. Why 10? Because 10 has just 1 0. Since there's only one digit after the point, that means it's only 1 0 you are going to write in the power of 10. Whatever number in the power of 10 you're going to write has to be just 1 0. If you have 1.25, what you're going to do is, since there are 2 digits after the point, the number that will be under has to have 2 zeros, and it's going to be 100. That is 100. So that's what this part is trying to explain, that when you now write the decimal as a fraction, you express it over a power of 10, which is determined by the number of decimal places. Okay? So the third thing that you do is use that thing to create a fraction. Remember, by writing it over a power of 10, you have removed the decimal point. So what you now have at the top is a clear number, a straight number that is looking whole, separated by a horizontal line, and then below you have a power of 10. So that you use to create the fraction, and you simplify it. What does simplify mean? You simply break it down till you can't break them down further. For instance, if you have 2 on top and 10 below, we know that 2 is an even number and 10 is also an even number. So 2 can divide 10. Okay? 2, remember, is the smallest even number, and it can divide any number that ends with an even number or with a 0. So since it's 2 over 10, that means you can break it down. So 2 will cancel 2 at the top, it gives you 1. 2 cancels 10 below, it gives you 5. So you're going to have 1 over 5, which is 1/5. That's what this last part is trying to explain. Create a fraction and you simplify the fraction. Please take note of these steps, because we're going to use them to solve some problems and see how this works. Okay? First, you count the number of decimal places that are in that decimal number, because the number of decimal places that you have will determine the power of 10 you're going to introduce as your denominator. The denominator is going to be a power of 10 that is determined by the decimal places, the number of decimal places. So once you have figured that out, you use that to create a fraction. How? You now use the decimal number as your numerator without the decimal point. You rule your horizontal line, and then below will be the power of 10 that you have introduced. What do you do last? You simplify that fraction, and you have your fraction which has been coined out of the decimal number. So we're going to take some examples. Yeah, we look at some examples now. Okay, so the first example we have here is 0.5. We're trying to convert 0.5 to fraction. So remember, the first rule says you determine the number of decimal places that you have in the decimal number. Now, these are decimal number. So how many decimal places do we have? We have just one. It's only one number we have after the point. That's what is meant by the number of decimal places. So we have just one. That means the power of 10 we're going to use is going to carry only 1 0. Since it's just one number after the decimal point, the power of 10 we use carries 1 0, and that's the number 10 itself. So this is going to now be 5 over 10. You're not going to use your point again. You're not going to repeat this point again, because you have introduced the power of 10 as the denominator. You have introduced the power of 10, so you cannot use your point anymore. So it becomes 5 out of 10. Okay? Now remember what the last rule says. A fraction has already emerged. We can already see a fraction. So what do? We simplify. A fraction has been created, so the last step is for us to simplify this. Now, this number here is 5 and this is 10. We know that we have a number that can divide through these two numbers without a remainder. A number that can divide through 5 and 10 without a remainder. And that number is 5 itself. So 5 cancels 5 is 1. 5 cancels 10 is 2. So our answer here is half, 1 over 2. So 0.5 is the same thing as 1.2 in fraction. Let's see if we can take another example. Example 2. Okay. Let's look at 3. Okay, sorry. Let's look at maybe 0 convert. Example 2. I hope it's not looking muddled up. Convert 0.75 to a fraction. Convert 0.75 to a fraction. Now going by the rules or the steps we observed or we looked at, the first part there, or the first step, is to check the number of decimal places. And that simply means check how many numbers or digits you have after the point to the right. So if you look at this number, we have 1, 2. We have 2 numbers after the point, right? Good. So let's write 0.75. Okay? So we have 2 numbers. That means the power of 10 that we're going to use is the power of 10 that has 2 zeros. And the power of 10 that has 2 zeros is 100. It must be 1. Okay, so it is 100. So this 100, remember, is the denominator. So we roll our horizontal line. And what happens with our 0.75? We discard the point. Okay, we bring out the raw number, we bring out the number itself without the point. So the number is 75. Okay, so the number is now 75 out of 100. So remember, our last step is to do what? Try and simplify these numbers, this fraction. It's already looking like a fraction, right? A fraction has been created already. So we try to simplify it to get what we are actually looking for. Now, if we look at these two numbers again, we see that the first one ends in 5 and the denominator ends in 0. Okay, so what number do you know that can divide through a number that ends in 5 and the number that ends in 0 without leaving a remainder? Is 5. Okay, so 5, we use 5 to divide 75. 5 into 7, that gives us 1. There's a remainder of 2. This makes 25. 5 into 25 is 5. You roll your horizontal line. Okay, so 5 into 100. So let's take it step by step. So first do 10. 5 into 10 is 2 times. Nothing remaining. So the second 0, we add it. That gives us 15 over 20. So if we look at these two numbers, 15 ends in 5, 20 ends in 0. So 5 can still divide these two numbers. So 5 divides 15. It gives us 3. You roll your horizontal line. And then 5 divides 20 gives us 4. If you look at 3 and 4, there is no number that can divide those two further. So this is the fraction we are looking for. That means 0.75 is the equivalent of 3 over 4. That's 3/4. I hope this is clear. Now I'm just going to show us one last interesting example, okay, that we a kind of mixed number, something that will give us mixed number. That's just the last one I'm going to show us. So the last example we're going to look at is 2.5. Convert 2.5 to a fraction. So if you recall the last two examples we looked at, they both started with 0. Okay, 0 point this, 0 point that. Okay, the first one was 0.1 single digit and the second one 0.2 digits number. So we're done with that. Now the example I'm going to show you now, you can see there's a whole number. It's not 0. There's a whole number before the point and then the number after the point. It's for a reason that I'm showing you this, okay? Because what it's going to yield is not just a straight fraction, it's going to give you a mixed number. So let's see how this goes. Now again, the same rules apply, the rules we used for the other two examples. How many numbers do you have after the decimal point? You have just 1. So again, the power of 10 that you're going to use has to have just 1 0. Just have one number here. So the power of 10 you're going to use, is the one that has just 1 0, which is 10 itself. Okay? So what happens to the point? It disappears. And up here you will now have 25. It's exactly the same thing. Okay? It's just I want you to see what it will yield at the end of the day. So now you have 25 divided by 10. Are we ready to go? Let's go. Let's simplify first, then we'll see what we do at the end. So these two numbers, one ends in 5, one ends in 0. So that means 5 can divide through them. So here you have 5. 5 divided 25 is 5. And 5 divides 10 is 2. So our new fraction is 5 over 2. Now we know this is not proper, right? In our lower class, we must have looked at different types of fractions, like fractions, unlike fractions, proper fractions, improper fractions, mixed numbers. Now, if you have the numerator bigger than the denominator, is improper fraction. This denominator is too small to carry this numerator. It can't carry it. So you don't leave it like this. So what do? We simply divide. Remember, it always comes back to dividing the numerator by the denominator. Okay, so now we're going to divide 5 by 2. How many 2s? How many groups of 2 can you get from 5? 5 divided by 2 is what? Is 2. Let me not treat you like you are grade 1 students. You are big boys and girls, okay? So 5 divided by 2 is 2. And 2 times 2 is 4, which means there's a remainder of 1. So that one that is remaining, you will write it as your numerator. And then your 2 remains as your denominator. Do you understand what we did here? Let's go back again. Okay? Now this is the number we're trying to convert. How many digits are there after the point? Just 1. So that means we're going to use 1 and 1 0. That's 10. Because it has just 1 digit after the decimal point. So we use 10 with 1 0. So now the point here disappears. So our number becomes 25. Right? Becomes 25 divided by 10. Now if you look at 25 and look at 10, both numbers can be divided by 5 without a remainder. So we're trying to break it down to make the process easier. So 5 divides 25 is 5. 5 divides 10 is 2. So you have a new number now, which is 5 divided by 2. Okay? And this we say is improper. We can't leave it that way. This kind of fraction cannot stand. Okay? Because the number below is smaller than the upper number. It can't carry this number. So what do we do to stabilize this fraction? We divide the numerator by the denominator. So let's pull out the number of 2's we can from this 5. How many 2's can we get from 5? Is 2. And 2 times 2 is 4. And when you take away 4 from 5, you have 1 that is remaining. So that remainder now becomes the numerator, while the 2 remains as the denominator. So if you look at this number we got, we didn't just get a straight fraction, we got a mixed number. 2 whole number, 1 over 2. That is 2.5. So that means that 2.5, which is a decimal number, is the same thing as 2.5 in fraction. So this is where we're going to call it a day. Please go over this video again. That's the good part about the video. You can play it for as many times as you want until you gain the understanding that you desire. Okay, I encourage you to do that and practice as much as possible. Your mathematics textbooks, you have some questions there that are at your level. So try your hands on them, okay? And do everything you can to gain mastery of this concept. So I hope to see you again next week. Until then, stay blessed and stay safe.